Hello everybody and welcome back to Unit 9 of Regents Chemistry where we are talking about solutions. Today we'll be focusing on the solubility curves. The main focus is to look at table G, but along the way you guys will just talk about different types of solutions based on its concentration and then based on solubility, and then we'll see how we can use table G to find the solubility and the types of solutions. So when we talk about the types of solutions based on its concentration, there are two main types, the concentrated solution and a dilute solution. So concentration basically is how much solute do we have in our solution. So if you look at this picture, we have the solute particles represented by the blue circles and we have the solvent particles represented by the purple circles. Now, if you guys notice here, the first picture has a lot of those solute particles, a lot of blue circles. That represents a concentrated solution, which is a solution in which we have a lot of solute particles in a given amount of solvent. However, in the second picture, you will now notice less amount of those blue particles, which means we have less amount of solute. So that represents a dilute solution, which basically is a solution where we have a small amount of the solute in a given amount of solvent. So in chemistry, we dilute the solutions a lot because sometimes we are given a solution that is very, very strong. We don't need it to be that strong, so we need to dilute it, which means we just make different solutions out of that thing by adding a lot of water to make sure that we have a very small amount of solute left in the solution that we want to use at the end. So normally we are given this stock solution, which you guys see here. Stock solution is basically the solution that we start with. Now this one right here is very concentrated. It has a lot of solute. So let's say this is a solution of an acid and we have a lot of acid in there. And we don't want to use that because remember, acids are harmful, so we want to make sure that the solution that we are using has less amount of acid in it. So what we do is, let's say we take 10 milliliters out of this solution and we pour that into this bottle, which is called a volumetric flask. And let's say that flask is of 100 milliliters. So we pour 10 milliliters from the previous solution in this, and then we fill it up to, there is a mark on this flask that tells us that this line is representing 100 milliliters. So we fill it up with water until that mark. So now we have this new solution that has less amount of the actual acid that we started with. And we can keep doing that. Let's say we still need a more dilute solution. So we can take 10 milliliters from our solution 1 and we can pour that into another bottle, fill it up with water. Now it has an even less amount of solute. We can do that one more time. So take 10 milliliters from the previous one, pour that in a new bottle, fill it up with water. Now we have an even more dilute solution. So we do this a lot in chemistry because we want to make sure that the solution that we are using is the one that we need and it's also not that harmful. And this process is normally called serial dilution because we are basically just taking different steps to get the dilute solution that we want. Now, let's talk about the types of solutions based on its solubility, which means how well our solute can dissolve in a given amount of solvent. Because we can try to dissolve as much of solvent if we want to dissolve, but it doesn't always dissolve. So based on that, we can have three different types of solutions. We can either have an unsaturated solution, and this is where the amount of solute that we poured in, it has completely dissolved, and we can still, if we add more solute, we can definitely dissolve it. The second type is a saturated solution. Now this solution is the one that has reached its limit. It has dissolved all of the solute that we added. However, it can not dissolve any more of the solute. So if we add any more solute, it's just going to remain undissolved. And finally, we have a supersaturated solution, which is the one where we just keep adding more and more and more and more and more solute, but it just doesn't dissolve. So one thing that we are changing in all three of them is that we are just increasing the concentration, which means we are increasing the amount of solute that we are putting in that same amount of solvent. And then based on how much solute we have, it's one of the three types of solutions and how well it dissolves. So table G in your reference table packet has the solubility curves for different substances. And using these curves, we can identify that at a specific temperature, or if we have this amount of solvent, which is water in this case, if we have this many grams of our water and we are at this temperature, is this substance going to dissolve? And based on that, we can identify what type of um, solution is it. Is it going to make a saturated solution? Is it going to make an unsaturated solution or a supersaturated solution? So let's quickly explore this table. And guys, we'll see that at the x-axis we have the temperature, and then on the y-axis we are given the solute per 100 grams of water. And then all these curves are basically just curves for different things. So we see a curve for hydrogen chloride, we see a curve for ammonia, we see a curve for sulfur dioxide, and just all of those elements. Now, if you have to identify a saturated solution from this, which means a solution where we have dissolved the maximum amount of solute that we can dissolve, and it can just not take any more of the solute. It won't dissolve. The lines that we see in this graph, they represent a saturated solution. What we mean by that is, let's say we look at potassium nitrate, KNO3. At 70 degrees Celsius, the maximum amount of salt that can dissolve in 100 grams of water will be 134 grams. So basically, here we are at 70 degrees Celsius. And then if we also draw a line with the y-axis to see how many grams of this substance is going to dissolve in 100 grams of water, that turns out to be about 134 grams. So if we dissolve 134 grams of potassium nitrate in 100 grams of water at 70 degrees Celsius, it's going to be a saturated solution, which means this is going to dissolve. However, we cannot dissolve any more of this solute in the water. So if we add more potassium nitrate, it won't dissolve. The unsaturated solution, as we just said, is when we have less solute present in our solution, which means there's still room for more. We can add more solute and it's still going to dissolve. So if it's the less solute, then that means these lines that we see for each substance, if we have the amount of that substance below the line or less than that line, then that would represent an unsaturated solution. For example, if once again we look at potassium nitrate, and this time I say we are still at 70 degrees Celsius. However, instead of 134 grams, we only have 130 grams of potassium nitrate. So there we have that line for 130 grams. And if you guys observe that carefully, you will notice that that specific point is below the line for potassium nitrate, which means this is an unsaturated solution. We can still add 4 more grams of potassium nitrate. They are still going to dissolve until it reaches that limit of saturation. And then finally, we have a supersaturated solution, which is the point where we have added a lot of solute and it just cannot dissolve anymore. Just some of the things to remember about this solution is that this is a very temporary situation, because if it cools or something, it can actually make precipitate. So it's very unstable, and depending on like what we do in that situation, it can either precipitate or crystallize. So now, because in this case we have more amount of the solute, that means this is going to be the case when at a specific temperature we have the amount of solute that is above the line. So for example, once again, if we look at potassium nitrate at 70 degrees Celsius, if we say that we now have 137 grams of potassium nitrate that we are trying to dissolve in 100 grams of water, if you look at that point closely, there you'll notice that this point is above that line for saturation, which means we now have a supersaturated solution. Alrighty, so practice this stuff as much as you guys can. That's it for now. I'll see you guys in the next one.